Hi guys, welcome to week number 10 of operating system course. We will be studying mass storage structure and file system interface today. So it's not gonna be a very lengthy lecture because these concepts, most of these concepts we already know because we play with our computers every day. We know what a file system is, what a hard drive is. So I'm not expecting this lecture to be very long. But obviously I am going to go through some technical parts of it, and I will move to my virtual machine in Ubuntu and run some commands for you on I'll be running different commands on how to partition your hard drive, how to mount your hard drive, and so on. So don't expect this lecture to be very long, which is a good news, I guess, because most of our lectures have been very long. And since we are reaching at the end of this semester, at the end of this term, we are not left with too many topics, as you can see in this course flow as well. So this is where we are right now, and we are left with only 1 week, which is more related to security and protection. And then in week 12, as you already know, that we are going to have some presentations, and we'll have some revisions as well. So I think we have learned quite a bit in this course. It's a very comprehensive, detailed course, as you might have already known. This course of computer science is considered one of the most detailed courses. That's why maybe students think that this course is very difficult. The other course that matches the difficulty or the details of this course is the data structures and algorithm course. That is also quite detailed. So you can imagine that this course is normally data structure course is normally the prerequisite for this course. So you should already know data structures and programming courses, other programming courses, before you dive into this course. So but I think we have done pretty good job, and I can see that you guys are learning a lot, which is a very good sign for me. For me, as I told you at the beginning of this course, the most important thing is that you guys learn new concepts. You guys learn different things that can help you in your practical life, in your professional life. So this is my aim. I'm sure as a student, this is one of your aims, and the other aim is to get marks, which I can see that most of you students are already doing pretty well. I can see that from assignments. And I'm really excited to see what you guys do with your project. And we are left with only one assignment, which is assignment number 3, which I'm planning to circulate maybe next week. And it's not going to be very detailed, very long assignment. I'm gonna keep it short. I was expecting to give you this assignment this week, but since you guys are already doing assignment number 2, or maybe just got done with assignment number 2, I don't want to bombard you with another assignment since you just got done with one of the assignments. And I know it's a lot of burden, and especially since we are going through very tough times of this pandemic right now. We already have a lot of depression, staying at home, can't go out to see our friends and so on. So maybe getting a little bit of break is always a good idea. And I can see, it's up to you guys, and I know you guys have a lot of pressure, but I would highly recommend and suggest that please take some break, at least 1 or 2 days during the weekend if possible, not to go towards your assignments and projects if possible. Just take some rest. It is very important in these days because there is not too much physical activity going on. So it's always a good idea to just relax sometime. And saying this and then giving you assignments, it's contradictory, but at least on my part, I try not to give a lot of burden to you guys. That's why I took out the midterm exam, and we already know that because midterm exam itself is a lot of burden, a lot of pressure. So exam, it's an exam, right? So exam has a lot of pressure. It comes up with a lot of pressure behind it. So that's why I wanted to take out midterm exam for you guys and replace it with assignments and projects. And I think it worked pretty well up till now. I'm gonna see how it works out with project, but you and me, we have done a pretty good job going through this course, and hopefully you guys do very good in your final exam. Of course, as I always say, I'll try my level best to at least prepare a video for you where I'm gonna solve one sample final exam for you guys, so that you guys actually understand what it's going to look like. this is my first term with you guys, so you should also know what is the style of final exams for me. That's why I really want to do that. So hopefully I can come up with one video where I can solve one sample exam for you guys for this course, and it will make you much more comfortable in seeing how it's going to look like. And it's very difficult, and it's quite different for us as faculty members also, because it's going to be online, and um, it becomes very difficult when it's online, because the type of questions you need to bring in, you need to work very hard. I mean, we are already all a faculty us, we are doing pretty hard on designing assignments and projects for you guys. We have to keep the academic integrity in place as well, so that's why we have to come up with ways where you guys don't fall in a trap, you guys don't feel it too difficult because it's online and we cannot meet as instructor and students. We still want to give you something where actually we keep academic integrity intact as well. So I hope it's going good, and we'll see at the end of this course how it all went. I really want to hear from you guys. I mean, if you have any suggestions. We are reaching at the end of the semester now, but it's always a good idea to hear from your students, what they think about the course, how is it going. I do meet sometimes different students on in my virtual office hours, so it's always good to hear from them, their feedback. It's always a good idea to hear that, right? So even if something is not working, I would love to hear that, because obviously it's going to help me improve myself as well, and it's not going to help me only, it's going to help the course as well, right? So we can further improve the course, and next time the students going to learn this course, they're going to get benefit out of it, and ultimately it's going to help the department of computer science as well. So feedbacks are always important. Like, I give you feedback on your assignments, it's always a good idea to get your feedback. So I wish you all the best, guys, for your projects. I've already assigned the projects. Some of the students already sent me an email. The group leads have already sent me an email about their projects they're going to work on and about their team members. The others who haven't sent it yet, please do that as soon as possible, so that I can arrange the schedule for your final presentations as well. And better to get that as soon as possible, because if you have any problems with the scheduled time, you can always reach back to me, and we can have a different session then. So please send me your schedule, send me your group members and the project you're going to work on as soon as possible. Few of the students are still left, I mean few of the groups are still left, so please do that as soon as possible. And as I said, that we are left with assignment number 3, which I am planning to give you next week, and it is going to be from today's topic. You will see that this topic is not very difficult, and I'm expecting that the assignment I'm going to give you on this project is not going to be on this topic, it's not going to be difficult as well. So if you go through what I teach you today, then you should be able to solve this assignment pretty easily. I'm going to go through Ubuntu as well. I'm not going to spend too much time today on Ubuntu as well, and obviously not too much time on theoretical part as well, because it's very difficult to just tell you again what a file is, what a directory is, right? So you already know about that, so I'm just going to build my lecture on top of what you already know, and that's why this lecture is not going to be very lengthy, and hopefully you learn something new from today's lecture, although I'm sure you know a lot of things about all these things, but on top of that knowledge we're going to build some more knowledge, right? So again, these are the assessments. We are almost done with our assignments. Only one last assignment is left, which you should expect next week, at the beginning of next week, and then we are left with our final project, which I'm sure you guys have already started working on, and the final exam. So we are on track as far as the course flow is concerned. Only this assignment, we are a bit late. I could have given you this assignment this week, but again, as I told you, that don't want to burden you too much with too many assessments. So maybe we can take a break this week, and maybe next week we can have this assignment. This assignment is not going to be very lengthy, very difficult. I'm expecting you guys to complete this assignment maybe in a couple of hours. It's not going to be that difficult. This is what I'm expecting. So let's see how it goes. So let's get started with our topic of today. It's about mass storage and file system. We already know what a mass storage is. Mass storage is where you store your data, right? So it's normally the hard drives where we are storing our data. Now hard drives, this is normally the internal structure of a hard drive. So it has the structure is in circular form. So it has some sectors, then it has some tracks. There is a head. This head rotates on this sector, and this hard drive actually keeps on rotating, and it rotates at a certain speed. We normally call it RPM. It's written, I guess, somewhere. So it's RPM over here, which is called rotations per minute. And the speed for our hard drives these days is around 5400 or 7200 RPMs. And in order to access hard drives, a CPU needs a controller, right? We have seen this diagram before as well. So I'm not going into a lot of detail of what hard drive looks like, what is the architecture of a hard drive, because this is beyond the scope of this course as well. So we are not going there. Just wanted to show you that this is just a bird eye view of what hard drives look like. And if CPU wants to access a hard drive, it needs a special controller. We normally call these controllers disk controller, and we have seen this diagram before as well. So CPU, in order to get access to these IO devices, it needs special controllers. And what these controllers do, they help CPU access these things, because every device, for example a mouse, it has many vendors, so it might be from different vendor, and this USB controller helps us to connect the device from different vendors through a controller, which is a USB controller, considering that this mouse is a USB controlled mouse. And similarly for disks, there are different vendors in the world that are creating disks, but it has to be universal. There has to be some standard way of using this hard drive, and that is through disk controller. So CPU uses disk controllers to access the disks, and so on for other things. If you see, and you might have noticed, and we have discussed this many times as well, that CPU doesn't need a special controller for memory, for RAM, because CPU needs direct access to RAM, and this is the only place where CPU has direct access, besides having access to cache and registers. The other things, CPU doesn't have direct access, and operating system uses disk controllers for CPUs to give access to these devices for CPU. Now we are going to talk mostly about Linux and how we can access hard drives in Linux. So as you know, in Linux everything is a file. Similarly, a hard drive is a file. It's a device file, which we normally call as device drivers in almost all the operating systems. So in Linux, normally in order to access a hard drive, you need to access a file called device file. Now normally there are 2 or 4 IDE hard drives. Now these are typical hard drives. Our new hard drives are Scsi hard drives. So if you're talking about our IDE hard drives, HDA, normally they are called HDA, they can be accessed by /dev/HDA, and we're going to do a quick exercise on how to do that in a while. So this is how you do it. So if I have for example 4 hard drives in my computer, so one of my hard drive will be HDA1, then HDA, and then the other one is HDB, then HDC, and then HDD, right? So these are 4 hard drives, IDE hard drives in my computer, right? You might have only 1, you might have only 2, you might end up having 4. So there is another type of storage device or a hard drive that is quite in these days, which is Scsi, and lots of modern computers, they come up with these hard drives. They are pretty fast, and in order to access them, we normally use a file which is available at /dev/SDA, then SDB, and so on, just like this. So it can be SDC, SDD, and so on. We're going to see what their conventions are, how they are named, why they are named like this. We're going to see that in a while. So this is normally how your hard drives are available on different operating systems. So since we are talking about Linux, so I'm going to talk about Linux in general from now on. So in Linux you can access your hard drives like this, right? So if you want to access and do something, you want to format your hard drive, for example, you know that you have only one hard drive and it's going to be this hard drive. Now it can be HDA1, and we're going to talk about what 1, 2, and 3 are. So in order to use a hard drive, so for example you bought a new hard drive, the first thing that should be done is to format that hard drive. Now it's such a common practice that normally the new hard drives, they come formatted. So the vendors, they normally format your hard drive. So if your hard drive is not formatted, it cannot be used. So that's why normally the new hard drives, they are already formatted for you at the factory. I remember when I used to buy hard drives back in 90s, you still had to format them, but normally these days you don't have to worry about that. All the hard drives, they come formatted. Um, and sometimes your hard drive can have bad sectors. What is a bad sector? Bad sector is a sector that cannot be accessed by your operating system because of some reason, maybe because of the hardware. There is some bad sector, or maybe because of the partitioning, it was not done, maybe formatting was not done properly. So these bad sectors are normally handled by the drive itself, so you don't have to do anything special because of the modern hard drives being very smart, and the file systems, they actually manage those bad sectors. So if something is wrong with the bad sector, and your bad sector in your hard drive is because there was some hardware problem, then your file system will make sure that nothing is stored at that bad sector, and that bad sector is actually skipped whenever data is being stored. Otherwise, some of the bad sectors that are being caused by the hardware, by the software itself, they are normally fixed by reinstalling the driver and so on, so that are actually taken care of by drive itself. So first thing first, in order to use your hard drive, you need to format it. If you have not formatted your hard drive, you won't be able to use it. But current hard drives, the modern hard drives, they are normally formatted already when they come from factory, so you don't have to worry about formatting them again. Next thing is you need to partition them. Then the question arises, why do you want to partition? For what partition means that, for example, you have a hard drive, let's call it HDA. This is your hard drive. And you want to have multiple drives. Let's talk about Windows for now, since most of the users, they use Windows, and it's pretty easy to explain in Windows terminology. So you might have a C drive, then you might have a D drive, you might have an E drive, and so on, right? So you might have these drives. What are these drives? These are basically partitions, different partitions that are created on your hard drive, because maybe, for example, you want to store operating system is normally stored on the active primary partition, which is normally C in this case. Now you might have noticed that why I normally use C. When computers came into being, then A drive was normally given to your external drives like floppies and so on. A and B, normally they were given to your floppy drives, because hard drives were not in those days, but they still remained in your computer when hard drives came. So A and B were still given to your floppies when hard drives came. So the other drive that could have been given to hard drives was a C drive. So this is the convention which Windows is still using, Microsoft is still using. They normally still use C drives, although the A and B are still not given to anybody. I have not seen any floppy drives, because computers have now ditched floppy drives. But if there is a floppy drive, you might end up seeing an A drive or B drive sometimes. So having said that, so you have a hard drive, you might have you want to have three drives. Normally your operating system is installed on primary drive, which is the C drive given partition. So operating system is normally on C drive. The other drives, you can store your maybe documents here, maybe your music and media over here, or games or something. This is how sometimes people organize them. But the other important concept that comes with partition is to have multiple operating systems installed on the same hard drive. Well, if there is only one drive, then it becomes very, very complex to have multiple operating systems installed on it. It becomes very, very complicated, right? You can still do that, but it becomes very, very complicated, and it becomes and you need advanced skills to do that. So in order to avoid this complication, what normally happens is you partition your drive into multiple partitions. So you install one operating system on C drive maybe, and another operating system on D drive or E drive, right? So these partitions actually appear as different hard drives for your system. So that's why if an operating system is launching from C, it will say that, okay, C drive is a separate hard drive, D is a separate hard drive, E is a separate hard drive, and so for this operating system as well. So if you want to have different operating system installed on your same hard drive, it's always a good idea to do partition. It makes it less complicated, and it makes operating systems easily live onto different partitions, because then operating system can store a lot of its stuff on the drive it is stored on. Similarly, if we don't talk about Windows in general, hard drives in Linux and Mac OS, they use pretty much same concept. It's just that they don't use drive letters like this. They use different file systems and different partitions. And you might have seen in in Mac OS, or if you're using Linux, you might have seen that there are different drives and you can give them different partitions, and you can give them different names. You want to still call them C drive, D drive, or you want to still call them operating system drive and music drive, or whatever. It's up to you how it makes your life easier, saving all this stuff on your hard drive. So one of the major advantages of partitioning your hard drive is to have multiple operating systems on your hard drive, on your single hard drive. Obviously, if you have multiple hard drives installed, HDA1 and HDA2, then you can install one operating system on hard drive A and one on hard drive B. That makes it even better, right? So these are partitions, and that's why you do partitions. Then how does it actually work? I mean, how does your operating system, how does your system actually knows where operating systems are residing? When your system boots up, and we have talked about this in great detail when we were talking about processes, and when we were talking about in initial lectures about generally what is the procedure or what is the process or step-by-step execution of your operating system. But let me quickly go through this slide because it is directly related to partitions. So when your computer boots, your BIOS boots first, right? So it boots first, it checks your hard drive first, it will check your hardware in general first. So it will check your hard drive first. So in hard drive, if hard drive is there, which is expected in modern operating systems, in modern systems, then BIOS actually checks for a record in your hard drive which is called a master boot record. This is the first record, first sector of your hard drive, and BIOS, after checking your hard drives and other hardware, it will go to this hard drive to see what to do next, right? Now it will read the first sector. Now there are different sectors on your hard drive, right? It's not a memory, it's a hard drive maybe. So this is going to be your first sector of your hard drive. So the first sector of hard drive will be read by BIOS itself, and normally at this master boot record there is a small program running. So MBR, or master boot record, actually runs a very small program in it. What it does is it reads the partition table. So basically there will be a partition table. I'm making it very simple for you, but normally it's quite complicated. Now partition table contains the type of partition, number of partition, and which partition has operating system, which one is inactive. So there are multiple entries in this partition table. I'm making it very simple for you. So there is going to be a partition table which contains, each record of that table will contain a partition. For example, HDA1. In HDA1 you contain operating system maybe 1 over here. Then which one is active? Operating system 1 is active, this partition is active, or some other partition is active. So this partition contains details about these things. So after reading this partition table, your system, what it can do is it will check for what partition is active. Now if you have multiple partitions, for example you have C drive, D drive, E drive, now which of these partitions are going to be active? That is very important to know, because your operating system resides on active partitions normally, right? Because if BIOS, after reading master boot record, does not have any system to hand over the computer to, then it's not going to work, right? And BIOS is going to hand this over to your operating system, your initial operating system. And which operating system? You might have an operating system on C drive, then another one on E drive, D drive, and the other one on E drive, for example. Which operating system BIOS should give the control to, right? So it normally starts with the active partition, whichever the active partition is. Not necessarily C has to be active. Your active partition can be D, and there is Linux over here, there is Windows here, there is Linux here, there is Mac OS over here, although you don't do that normally, but for the sake of understanding this. So your active partition can be D drive, which means that since this partition is the active partition, whatever operating system is on this partition will run first, right? Not necessarily C drive has to run first. But normally for conventions, normally in Windows we have C drive, we have active partition, and on that active partition we normally call that active partition C drive, and on that partition Windows is normally installed. So it checks for that active partition, and that then operating system starts loading, and then operating system takes care of everything, right? So this is how normally your computer starts, and then this is how the handle or control is given to your operating system. Now another important concept that comes is the extended and the logical partitions. Normally your hard drives can be partitioned into 4 partitions only. Your hard drive can have maximum of 4 partitions. We normally call them primary partitions. So you can have maximum of 4 partitions on your hard drive. But you might have seen that some computers do have more than 4 partitions like this, right? Then if they can have only 4 partitions, how they had G partition also, the 5th partition also? Well, there is a trick to do that. If you want to have more partitions in your computer, what you can do is you can take advantage of extended and logical partitions. So normally you have only primary partitions. Now you can divide a primary partition into a sub partition, which is normally called an extended partition, and inside that extended partition you can have logical partitions. Now these sub partitions, whichever partitions you are making, so for example over here, this is your primary partitions. Let's call this P primary partition. This is also a primary partition. This is also a primary partition. So F is now divided into another partition, which is called an extended partition. So this partition is now divided into an extended partition like this, and inside this extended partition we have 2 different partitions, which are logical partition, which is F and G, right? So these are 2 separate partitions. So these sub partitions or logical partitions, they normally behave very similar to your primary partition. So a user will not know if this is a primary partition or a logical partition. So they will still appear to him as a primary partition, and you will have drives like this. And there is no difference in speed as well as far as our normal operations are concerned. But if you are doing something very critical that needs your primary partitions, obviously primary partitions would be considered much higher in speed. Not much higher in speed, but they are, if you are performing normal operations, then there is no difference in speed. But if you are performing some operations that are very critical, then you might need to consider putting them on primary partitions. So this is how normally it is done, and it looks like this. So this is our hard drive. So the first sector of the hard drive contains an MBR, master boot record, and this second record, I'm just saying this over here, but normally not necessarily it has to be here. So maybe at second record your first primary partition C drive is starting, and then you have a D drive over here. What you want to do, and maybe there is an E drive somewhere down there, and then maybe there is let's assume there are 3 different partitions over here. What you want to do is you want to have 2 more partitions. So you already have C, D and E, and you want to have 2 more partitions. So in order to have 2 more partitions, what you have to do is you have 1 more partition left, because you can have maximum of 4 primary partitions, and this primary partition will now be converted into an extended partition, which will have inside it a logical partition. Maybe then we can call it F drive and G drive inside it. So this is going to be my extended partition, which inside it contains the logical partition. Now how does it actually work? So this is again this is one of your primary partitions, which has been extended to contain some logical partitions inside it. So this one of your primary partition is now converted into extended partition, so that it can be further divided into 2 different more partitions, right? So that's why we call it an extended partition. If you wanted to keep this to a same one single partition, then there is no need to have an extended partition. We can call it still a primary partition. This is a primary partition, this is a primary partition, this primary partition, and this primary partition. But for example, the aim is to have more than 4 partitions. Then in that case, what we can do is we can just convert this primary partition into an extended partition, and then extended partition can then be further divided into a logical partition and another logical partition. So we can have one partition here and another partition over here, right? So this is what the concept of extended logical partitions is. What I want to do is I want to see if I can show you very quickly disk management. So you can see over here that in Windows, since I'm using Windows, you can have something like this. There is a utility call or a program that is built into Windows that is called disk management. So in this management, you can see over here that these, and you can see down here that the blue color is the primary partition. So I have these 3 primary partitions. If I wanted to have 2 more partitions, what I could do is I can, obviously since I don't have space, first of all I have to split this Windows maybe C drive into unallocated space first. If you see, there is a black color over here for unallocated space. I don't have any unallocated space over here, but if your hard drive has some unallocated space, or maybe you want to create some unallocated space, what you can do is you can shrink volume like this. I mean, I don't want to do that because that's not my need, but if you obviously want to create more partitions on your system, what you can do is you can shrink your current partition if you do not have unallocated space. If you have unallocated space, then it's easy for you to create another partition and then work on that. So this shrink utility will allow you to shrink some of it and make it an unallocated space, and from that unallocated space what you can do is you can create some more partitions. Maybe that is an extended partition, and within that extended partition you can have logical partitions. And similarly for Linux, there are several utilities that you can use. There are some graphical user interface utilities also. There are some command line utilities also. Normally in almost all the operating system you will find a Fdisk utility, at least at a command line level you find Fdisk utility. That is available in Windows, that is available in Linux as well, in Ubuntu. I'm not sure about Mac, but it should be there. If it's not there, then they should have their default disk utility. I know they have a graphical user interface of disk utility by the name disk utility in Mac, so that is used. But for CLI, I think they still have Fdisk, so you can try, Mac users can try to find that out. So these are extended and logical partitions, and this is how they work, and this is why we need them. It can be an important question in your final exam. So what are the differences between a primary, extended and a logical partition? So if you don't understand this still, just rewind this video and go through all the details. If you still don't understand this, maybe we can meet during my office hours and I can explain it further to you. Then as I just said that normally in almost all the operating system there is a utility by the name Fdisk. At least in CLI, command line interface, you will find Fdisk. It is available for Windows, it is available for Linux as well. And then in Linux there is another utility, Cfdisk, that is a GUI utility. I mean, it's not really a GUI utility, but it gives you at least more options and more controls in CLI. This is still a CLI, but a better graphical user interface. And then in Linux we do have we call it, I think, disk utility, the same name as Mac, I guess. I'll show you that in a while, but Cfdisk is another utility besides Fdisk in Linux that you can use. And obviously there are some third-party utilities, very famous. Partition Magic is very famous. Gparted is very famous in Linux. These utilities are pretty good and they are pretty powerful when it comes to partitioning your hard drives. So if you are not happy with the CLI or the built-in disk utility of Linux, you can try these, and I'm sure you might have already tried this. If not, you can have a look at them, and they are pretty powerful. Now, as I said that for Linux at least, all of your files are every hardware in Linux is considered as a file. And in order to have this slide is more about the conventions we normally used in Linux at least. So what is happening normally is the partition number is appended after the name of the whole disk. So for example, if you are using hard drives HDD, then you normally use HDA convention. That's what is over here. And if you are using SCSI, then you normally use the convention of SSD, and then after that you use ABC, right? So this is what the name of the hard drive, this is where the name of hard drive comes in. So HD is actually the name of your hard drive, and in this case if you are using SCSI drives, the SD is the name of your hard drive. Then 1 to 4 are primary partitions. So if you see 1 up till 4, then it means that this is a primary partition. It's a primary partition. We know there are 3 types of partitions: a primary partition, extended partition, and a logical partition. Well, extended and logical are somewhat similar. Is that just that the logical partitions, they exist within an extended partition, right? So normally we have for numbering we have only 1 to 4 for primary, and more than 5 they are logical partitions, right? Okay, so this is how it is. So for example, if we consider HDA1, if we consider this, then what can we tell from here is this is your hard drive. So you have a hard drive which is not Scsi. This is what we can tell from here. So it's an hard drive. The second A thing over here, it basically is telling you that this is the first IDE hard drive for you, right? It's the first IDE. So you might have two hard drives, right? So the first hard drive will be HDA, the second hard drive will be HDB, third hard drive, just what I told you in the previous slide, third one will be HDC, right? I'm typing it in capital, normally it's all in lowercase, just like what we have over here. So HD is the name of your hard drive, the type of your hard drive. A is the hard drive. Is it the first hard drive? Is it the second hard drive? Is it the third hard drive? And the 1, 2 or 3 or 4 over here, they tell us whether it's a primary partition or a logical partition. Since it's a 1, it's a primary partition. So anything between 1 to 4 is going to be a primary partition. So this means, this whole thing means it's a hard drive that is on hard drive 1. Hard drive 1 I can tell from A, and it's a primary partition. So it's a primary partition on first IDE hard drive, right? It's the first partition on primary, it's the primary partition, first primary partition on first IDE hard drive, right? Similarly, let's have a look at this one. Now we know that this is not IDE for sure, this is SCSI. If it's IDE, then it will be HD, right? So SD means over here that we are using SCSI drives, right? Which is still a hard drive. And then B means that this is going to be my second hard drive, right? Now if it was SDA, then it's my first hard drive, just like what we had over here, right? So SDA is my first hard drive, SDB is my second hard drive, SDC is my third hard drive, right? And 7 over here, what does this tell us? This tells us this is a logical partition, right? Or an extended partition, right? Because if it was SDA2 for example, then this is our SCI hard drive, this is our first hard drive, and this is our primary partition, right? From here we can tell that since this is 7, which is definitely not between 1 and 4, this is our third extended partition. How do I know third extended partition? Because it's 7. So after 4 we have 5, 6 and 7. So it's our third extended partition, right? If it was SDB6 for example, it means that this is our SCSI hard drive, second hard drive, and this is our second extended partition, because after 4 we have 5 as first extended partition, 6 as second extended partition, and 7 as third extended partition. So these are normally the conventions we use for our hard drives. They are pretty important to know because this is how you get to know your hard drives. If you have multiple hard drives and if you are doing something about them, I mean you are formatting them, you are partitioning them, if you don't know this convention, it becomes very difficult for your operating system and you also to understand that, because the operating system might give you a different convention based on what is built into operating system, and you might be thinking of having some other other conventions, right? So it's very important to know which conventions are normally used in modern operating systems, and these are the conventions which are used, right? So I hope this makes sense to you. Let's move further. So we are done with partitions. So first of all we had hard drive, then within the hard drive we had partitioning. Then after partitioning, the other important thing comes is the file system. All right, so how do I save my files on my system, right? There has to be some file system. Now for Windows we normally use a file system called Mkfs. I'm not going into the detail of that because these file systems are quite comprehensive. I don't want to go into a lot of detail of those. Then we have FAT16 and FAT32, which are also used by Windows. Normally it was, it was used previously. Now Windows are normally using NTFS. For Unix based system we normally use ext2, ext3, and now we have ext4 also. Extended partitions, they are normally called extended, and then there is a 3 also. So we normally use this. Now what are file system? File system is basically an address space for your processes, right? Now if we don't know in our operating system, if we don't know what is on our hard drive and at what address they are available, it becomes very difficult for us, right? If hard drive is just about addresses, then if you remember, we discussed about address spaces when we were talking about memory as well. If it's all about this, then it's very difficult to know where a process is starting, where the process is ending. Similarly, it's very difficult to tell where a file is starting, where the file is ending. So we need to have some address spaces, and these address spaces will actually give us the addresses of things on our hard drives, and based on these addresses we can go to file number 1 or process number 1 and process number 2. Well, when we are talking about normally the hard drive, we are talking about the programs, or we are talking about the files, because files are actually stored in, programs are normally stored as files in your hard drive. But when we are talking about main memory, we normally talk about processes or thread, right? We already know this. Now file system becomes very important uh, for the operating system to tell, okay, where do I start, where do I end, how do I know that this is where the file is starting, how do I know this is where the file is ending. This is all called a file system, right? And files are normally used to store all your programs, right, in modern operating systems. Now why do we need files? There are three problems that files overcome for us. Now the first thing is, if you are running a program or a process in memory, so let's assume this is RAM. If you're running a process in a RAM, and if you restart your computer, then everything in that process, all the changes you made to this process, they'll just go away, right? Because RAM is volatile, it will not keep anything inside RAM after the computer has booted, right? So you need to store something somewhere on the hard drive, so that next time you come, the changes you saved on your process or on your program, it remains intact, right? For example, you have created a Microsoft Word document and you have not made changes to, and you have not saved changes to it, and you restart it somehow, the changes will be lost. And that Microsoft Word is basically a process, right? It's a process. So in order to keep the changes, in order to make sure that the changes are not lost, we normally used files. So we store those information into the file. So even if when it restarts, the changes are saved, right? And memory normally has a very limited space. We might have 2 GB, 6 GB, or 8 GB or 16 GB of hard drive, but then that might not be sufficient, as we discussed when we were talking about virtual disk space as well. So that's why it's very, very important to have a hard drive, and in hard drive we have to have a mechanism where we know that where a file is starting, where the file is ending, just like the process we have in RAM, where we know that using the address spaces where a process is ending, where a process has started, what is the length of the process. So files help us in making sure that we, first of all, we store the information, secondly how that information is stored, and what are the running processes. Now similarly in files, what normally in address spaces in RAM, what can we do is, one process cannot share a memory of another process, we know this, unless and until there is a special scenario. But what if one process wants to share something with another process, right? Files can help us in that. For example, there is a Microsoft Word file that is being shared by Microsoft Word as well. Microsoft PowerPoint can share that file as well. So sharing becomes pretty easy with multiple processes as well, and files make it very easy for us. So that's why we use files. What a file is: file normally stores information. Files can be read, write, can be executed, and obviously you need to create the files first. And that's why I said that this topic is pretty simple, pretty straightforward, because we know what files are, right? We have been using files for years now. So you can create a file, you can write to a file, you can read from a file, you can execute an executable file as well. You can remove a file, obviously then this will disappear. Files can be managed by operating system, it can be managed by users as well. Some of the files that are important for operating system manages them. Some of the files that are for user programs like Microsoft Word and so on, those programs, they manage those files. But in general, all the files are managed by operating system, right? And the part of operating system that manages files is normally called a file system. Very simple, as I just told you, right? So just like what memory management unit does, right? It's basically a part of memory management. So memory manager, what memory manager normally does is it manages RAM for you, RAM for the operating system, right? And memory management unit helps memory manager in operating system to manage your your RAM, right? Similarly, file system or file system manager, some people call it, it's normally used to manage your files on operating system. Now there are different naming conventions, and in our modern operating system, every file should have a name, and that's why I don't think you can create a file. There is a trick to create a file with empty name, but it doesn't make sense, right? It's always a good idea to create a file with a name, and that's what modern operating systems expect from you, that you should have a name for each file on your system. Normally the operating systems offer 255 characters for your names. You should not have more than these characters. There is still a trick to have more than that, but default behavior is 255. And some operating systems, they are pretty case sensitive. For example, Unix differentiate between upper and lower case, so any file that is apple.txt and lowercase apple.txt, they are considered different. MS-DOS doesn't differentiate between them, so for MS-DOS both files are same, right? Then the extensions, we know that in order to differentiate between files, well, for operating system it's all about a file. So file for operating system, whatever that file is, for operating system it doesn't matter, but different programs can read only certain files. For example, a notepad. For example, a notepad can read a lot of files, right? You might have experienced that a notepad can read a lot of files. It not only reads the txt files, it can read for you some HTML files as well, right? It can read for you CSS files as well, right? It can read a lot of files for you. So notepad is one of those programs that is built to read a lot of files, right? But your operating system, for operating system, it doesn't matter what that file is. Operating system does not require you to have an extension. For operating system, a file is a file. But since we have in modern operating system, we have different programs that are used to read files. For example, to read a PDF, you need a PDF reader. For example, Acrobat reader or a similar program like that. If you don't have that reader installed on your computer, this file will not open, right? For operating system, it doesn't matter. For users, it does matter, because for operating system, it's just another file. But for a user wants to read that file, so user needs to have that reader or a program to read that file, right? So that's why modern operating systems do have file extensions, and those file extensions are for the programs that are used to read those files. For example, if there is a txt file, a notepad can read it. If there is an HTML file, a browser can read it. For example, CSS file, a browser can read it, or notepad can read it, and so on. So these are the file extensions, which are the characters at the end of your file after the period. So normally different programs can distinguish between different files based on their extensions, and they are pretty good concept these days in a modern operating system. They offer them. Then we have a file structure. Again, as I said, that for operating system it doesn't matter what an extension is. Operating system sees a file like bunch of bytes, right? They are just unstructured sequence of bytes for operating system. Operating system doesn't know what data is inside it, and operating system doesn't care what the data is inside it. For operating system, these are just bytes, right? But in order to read those bytes, you need special programs, you need special utilities. Just as I said that, if this is a PDF file, you need a PDF file reader. But for operating system, it doesn't matter. Operating system is just going to read them byte by byte, right? Now, there are some special operating system normally used in batch programming and mainframe computers. What they do is they consider each file as a record. So inside each file there has to be a record. Just like in Excel, for example, you have rows and columns, you have normally cells. So each row is basically a record in that, right? Each row is a record. So some of the older computers, they wanted your file structure to be in the form of a record. So each file is considered a bunch of records inside it, right? So old computers, they wanted their files to be structured in that way, that they are in the form of records, not in the form of bytes. But modern operating system, they normally consider them as bytes, and they access them as bytes. So I mean, why mainframe computers, they wanted this way? Because it makes it easy for them to search records, and they actually consider those files to have a record. If they are separate, for example, if this is a name age and phone number and email address, your batch computers or your mainframe computers, they consider it as a record and they want it to be exactly like that. If age is somewhere here, they won't be able to read it. They will say that, okay, this is not an email address, this is an age. Sorry, this is not an email address and this is an age. So they want certain characters to be at certain places, only then they'll be able to read it. And why they do it? Because they are programmed like this, and sometimes it's easier for them to search a record that way. Then the types of files, we normally have regular files, then we have directories as well. If we talk about regular files, there are many types of files, but normally if we divide them into two bigger categories, there are Scsi files and there are binary files. Scsi files are basically text. So if you are talking about Scsi, then they might contain text inside, and they might end a line with a carriage return, your enter on keyboard, or they end a file with end of file, or so on. I'm sure most of you have already gone through the programming languages and you know how to read from a regular file, an Scsi file. You might have been reading characters from the file. So I'm not going to go into a lot of detail, but one of the regular files is an Scsi file that contains text inside, can be numbers inside obviously, and you can read from that file. There are certain, if you're writing a program, then you can read and write using the file streams. For example, if you're using C++, then you can use Fstream for reading if stream and for writing O stream. But obviously, if you are not a programmer, you can still read those files using any editor. Notepad is one of the examples of reading the text files or Scsi files. The other types of files are binary files. These are not like Scsi files, and if you open them, for example, a lot of binary files, you can still open them in Notepad, but you will see some random characters and they are not going to make sense to you. And this is how they are. They are executable or binary files. They are not meant to be read by humans. They are meant to be read by machines. That's why you end up finding some random characters over there. So these are binary files. Then binary files, they do have some structure, and not necessarily all binary files have the same structure, so they might have some special fields that they need to follow, and these fields or headers, normally they are called, they are normally required by the program that reads it, right? So for example, if there is a zip file, that zip file might, WinZip or WinRAR might need this header, right, to read this file. Similarly, there is an executable file, for example .exe file. That exe file, if read by Windows, for example, it needs it to be in a special format, and it needs to have a header that might contain some information about where to start the reading this file, what is the data size, what is the text size, and so on. So that's why binary files are a little bit different than the Scsi files. Then we come to the file access. File access, again, you guys, I'm sure you guys have gone through the programming languages and you might have already know how to actually read those files, how to write those files, and you know that there are two types of files when you are reading and writing them. One is called a sequential file and the other one is called a random access file. Sequential file is, for example, if this is your file, then in sequential file, if you are, what I'm going to do is, let's create the file properly. So for example, if you are reading a file and you have a file, okay, so if you have a file like this, for example, this is your Notepad file, and this is your first line, and this is like your second line, and so on, and this is maybe your line number 100. So this is line number 1, 2, and 100. If you want to, so I'm talking about sequential files, so there is some data here, some data here, some data here, and in between there are some data lines as well. So if you want to go to line number 100, you have to start from line number 1 line and then read line number 2 and then read all the 99 lines before you can actually go to line number 100. This is called a sequential access. So you have to go in a sequence. It's not possible to jump from line number 2 to line number 100. Even if you want to jump, your compilers are very, very fast, so they will still read each and every line, but as a user you might not notice it, but they have to go through each and every line, and this is called a sequential access, right? So some of the files, if you want to access them, they are sequential files, and old operating systems, especially the batch operating systems, they normally provided something like that. So they didn't give you an access to access line number 100 directly. You have to go through all the lines, only then you can access line number 100. But right now, modern operating systems with disks with hard drives, and with modern operating system, we normally use random file access. So we can go to any line. So even in editor, we can open Notepad and we can click our cursor anywhere, and it will take us to that line, and we can edit that or we can read that. Normally we use a seq variable. I'm not going into the detail because this is more of a programming thing. So you use a seq variable. So in programming, for example, in C++, you use seq p for writing, and then seq g for getting or reading the file. So using these two pointers, you can jump to any part of the file and can edit that or can read that, right? So this is called a random access file, where you don't have to go through line number 1 till line number 99 to access line number 100. You can directly go to line number 100, put your cursor anywhere if it's a graphical user interface, and start writing it over there, right? Then comes file attributes. What is a file attribute? We normally call them metadata as well, or attributes only. So metadata is more technical term. So what a metadata is, it's a file. It basically, these are the properties of your file. So if you go to, for example, let me go to maybe any file. This is the file, for example. If I go to properties, this is basically your metadata, right? This is your metadata. So everything over here is the metadata. It's the details about your file, right? It can be the size of the file, it can be the name of the file, it can be the last modified date, it can be anything. So all the details about that file except the content of the file is normally called a metadata or attributes of that file. Now different operating systems, they maintain different things about it. Some operating system, they contain a lot of details about that file. For example, file size, last modified author. Some operating systems, they do not contain a lot of information about that file, but modern operating systems, they normally contain a lot of information about the files. For example, in some of the cameras these days, they also contains geolocation. So wherever that picture was clicked, those pictures actually contain that information as well. Even in our smartphones, if you click a picture, they also contain the location. If you have given permission to your camera, then they actually contain the location where the picture was clicked. That's why if you go to some gallery apps, for example, image processing software, then you can see that they can actually show you the map of the location where you actually click that picture. For example, I think if I'm not wrong, iPhotos on Mac, it has a built-in capability for this, so it can actually show you the photos on the map where you actually click those photos. So those are all called metadata, or the properties of your file. And these are some of the many attributes as I just showed you. So there is a owner for this, you might have a password on it, who created that, modified date, and so on. So this is all called the metadata or attribute of a file. Then the operations on the files, there are several operations that you can perform on a file. Few of them are create. So you create a file, and when you are creating a file, you need to give it some file name. You need to give some of the attributes. Some of the attributes are by default taken by the operating system. For example, the date. You don't have to enter the date you created the file. Operating system takes the system date and put it over there, and so on. So you can create a file. You can delete a file, of course. Why you delete a file? You don't need it, or you need an extra space. When you delete a file, a system call is used. I'm not going into the detail of system call right now. We discussed about several different system calls when we were talking about kernel modules and so on. So it's just another system call of delete that deletes your file. Then open file. In order to read a file or write a file, you need to open that file first, and again a system call will be generated for opening a file, just like what we did for create a process and so on, create a thread. These are all system calls. And obviously, why you're opening a file? Because you want to read it or you want to write on it. That's why you want to open a file, or you might want to make some changes to the attributes of that file as well. And by the way, when you are opening a file, it has to be in RAM. I mean, only then it can be read. Otherwise, it won't be able to be read, right? Then you can close the file if you are no longer reading the file or writing to the file. It's always a good idea to close that file. Our modern editors like Notepad, if you click the cross button on the graphical user interface, it closes the file. But when you are writing a program, for example, you might have already known when you are writing the files using C++ and so on, you use fstream.close to close that file, so that if somebody else wants to use it, they can use that file as well. Reading, obviously you can read the file. In sequential files, you cannot jump from one line to another line, but in Random access files, you can use seek variable to jump from one place to another place, and it's all about data you are reading. And then write, you can write, obviously again seek variable can help you go to the end of the file or maybe to the middle of the file where you can write. Append is another operation that is used for appending something to the end of the file. So if you want to write something to the end of the file, there are operations like when in your C++ you can use a directive like this, append to the file. So we know this. So if you want to append to a file, it will append something to the end of the file, and obviously it's going to increase the size of the file if you are adding something to the file. Then seek operation, I already told you, I'm not going to go into the detail. Get attributes, there are some system calls that can help you get the metadata of the file. So sometimes you want to change, for example, the details about the file. Well, graphical user interface of many software, they give you flexibility of doing that. For example, if you convert this, for example, into PDF, if I convert this into PDF, you can see that I have a lot of information over here that I can change. So I can specify, so this is File Explorer of Microsoft Windows. So author detail I can change over here. So this is using a get attribute, so it's already getting the attribute and putting it over here. Similarly, for date modified, this information is already taken. Similarly, title over here, this has already been taken, and so on. So these are the things, I mean, you can use for your system, and these are again system calls that can be used to get information about your attributes of your file. Similarly, setting an attribute, you can set an attribute. For example, you want to change the permission of a file, you want to change the creator of the file, for example. If you have access to that information, you can use set attributes as well. You can rename, we know that. Next comes the directories, very similar to what we have for files. In order to contain your files, we normally use a container called directory. In Windows we call them folders, in Linux we call them directories. So they are used for structuring it. Now there are different types of levels. So single level directory systems are the level of directory systems just like this, where there is only one directory on your system, only one folder in your system, and all the files are inside this folder, right? This is handy when you have less number of files, and since you have less number of files, you just have one folder in your whole operating system and everything is inside that folder. It becomes easy, it becomes very fast to search for files. But normally in modern operating system we use hierarchical directory system, which looks something like this. So there is a root directory, and we have talked in great detail what a directory system looks like. So we have a root directory, then we have inside some other directories. Inside the directories we have some files, or within directories we have some more directories, inside them we have more files. So this is how your modern operating systems work. They have directories, inside those directories they have more directories, inside those directories they have some subdirectory, more directories and files. So this is hierarchical directory system looks like. Then we have path names. Now these path names can be for files as well, that path names can be for directories as well. We normally have two types of path names. One is called an absolute path name, and the other one is called a relative path name. The absolute path name, easy way to know a path name if it's an absolute or not, is that we see the first character. If that first character is a separator, just like what we have over here, these are the separators, right? If a path name is starting by this separator, it means that it's an absolute path, right? And normally for Linux, even for Windows, it starts with root directory, the top directory, right? So this is for normally for Windows we use the backslash, and for Unix systems we use the /. So this looks like an absolute path. And then there can be a relative path as well. Relative path means a path that is based on something else. So for example, an example over here I have is, so you want to copy a file that is in user AST mailbox to a place which is like this, user AST mailbox.back. So basically what you are doing is you are copying this file into the same directory, right? Into the same directory. So this is the directory, and you are copying this file, but what you're doing over here is you're just taking the backup of this file. So what you are doing is you are copying the same file here, but changing the extension to .back. So file name is basically the whole thing, right? That's why operating system will know, okay, this is a separate file, this is not the same file, right? instead of doing this, you can use relative path names. So if we believe that our working directly currently we are in user slash ast, which means that we are currently working in this directory, then we don't have to specify the whole path over here. We can use the relative path. So what we do in this case is, since we are currently working in this directory, I mean this whole directory, then we don't have to specify the path over here by saying this. We can use just the name of the file and the name of the backup file. That's it. So this type of stuff is called a relative path name, right? And these are something like this. In Ubuntu we normally have a directory structure like this. So it starts with the root directory, which contains inside some of the directories, and we have discussed them in great detail. I'm not going into the detail, but normally dot means the current directory. So if I'm using it's here somewhere written. So if we have a full stop, it means the current directory, or pwd is normally used to get your current directory, present working directory. But full stop means that you are in current directory, right? You can access your current directory by doing a full stop here as well. Then dot dot means the parent directory. So you can use dot dot. So for example, if you are using Linux and you write cd space dot dot, it will take you to the parent directory or the previous directory, right? These are two conventions which are used in Linux. Similarly, directories, you can create directories. Obviously, I mean, normally directories are empty when they are created. You can delete a directory, of course, since you don't know. And you can open a directory, close directory, read directory. I'm not going into the detail. Then you can rename the directory, you can link the files, and you can unlink the files. This is pretty much it for the theoretical part. What I want to do now is I want to quickly show you some tools that you can use in Linux to perform some operations of partitioning, mounting, and making a file system and so on, because I'm planning to give you an assignment on this. So that's why I want to quickly go through these special instructions that can be used. These are basically utilities that you can use in Linux to perform different operations. So let me quickly go through this so that you actually get an idea of how we can perform these operations. So what I want to do is, first of all, let me tell you about the graphical user interface, although the assignment will not be graphical user interface. So what I want to show is like this. So Fdisk Utility is a graphical user interface for your Ubuntu. So this is a graphical user interface. You can take this, you can work on this. Maybe you can check file size, edit partition, create a format partition. So this is a graphical user interface. But for assignment, obviously I would not ask you to do graphical user interface. I want you guys to do it through CLI. Obviously this will give you more information, more detail about your work. So I'm going to talk about Fdisk. So Fdisk is basically a utility that is used for doing a lot of things with your hard drive, right? So one thing it can do is you can get a list of all the drives on your system. So for that I can do something like this, fdisk/l, and normally you need sudo with that, because Fdisk is normally used with root privileges. So when I did this, it showed me the list of all the drives attached to my system, right? So it showed everything. But since I'm using an Scsi drive, these are my hard drives. So for this guest system on my VirtualBox, I have 15 GB of space, which is my. So if I see from here, what it tells me is that I have. Where did it go? Okay, so here. From here I can see that I have SDA, which means that it's an Scsi drive, and then obviously this is one hard drive. And if I go for more detail over here, which I can get, by the way, by doing something like this, if I'm not wrong, fdisk-dev/sda and stack. Can I do this? No, I have to do -l on this. So as I showed you, that I can do the list of all the drives on my hard drive by doing this, or if I want to get very specific detail about a very specific hard drive, I can get that as well. So I wanted to get information of my only Scsi drives, so I can do something like this. Static over here is wildcard, which means that I can use anything after SDA will be acceptable over here. So anything that contains SDA into it, it will show me all these things. So you can see that I have currently these things. So I have SDA1 over here, which is FAT32 for sharing maybe between between my guest operating system and my Windows operating system, and then I have an extended partition over here. Then I have my Linux partition, which is SDA5, and a lot of information is provided over here. So in order to get the name of your hard drive, in order to get the capacity of your hard drive, and in order to get the type of file system on your hard drive, so this is the type means the file system over here. You can do Fdisk, right? So you can do Fdisk-L for all of them. If you want to work on specific hard drive which is maybe required for one of your assignments, you can do that for by doing this, right? Now for example, if I wanted to, so the first thing normally is to get to know about your hard drive, and Fdisk is just one of the many utilities. Cfdisk is another one. Sudo cfdisk is another one, which looks something like this, right? So it's a little bit of better graphical user interface, but obviously you cannot use mostly the, I mean, you can scroll with the mouse, but normally I don't think you can use mouse otherwise. So you have to use these commands and so on. So cfdisk is just another interface for you that you can use instead of using Fdisk. But obviously Fdisk gives you a lot of flexibility, a lot of power when you're using this on your hard drive. So after getting this, what you wanted to do maybe is you want to partition your hard drive, and actually I created this slide file based on the steps you normally take. So you normally start with your hard drive, then you format that hard drive, which is normally already done for you. Then you partition your hard drive. Once you are doing partitioning your hard drive, which is up till here, then you build a file system on it. Once you are done doing a file system, then you mount that file system on your hard drive. So we have seen our hard drive. So maybe I wanted to work on SDA hard drive in this case. So what I can do is I can do sudo fdisk SDA, and I wanted to work in maybe SDA2, I don't know, SDA2 for example. Oh sorry, you have to write down the whole full path like this. So when you do something like this, so this is where I wrote my command. So after this, the Fdisk utility will start, and it will start telling you that okay, the Fdisk utility has started, what do you want to do. So you can type M to get more commands. It's very comprehensive. It provides you a lot of details. So this is the menu for you. You can do all these things with your drive over here. So if I wanted to, for example, know the for example, list of free unpartitioned space, do I have any free unpartitioned space? If I do F, it shows me there is one unpartitioned space which is at SDA2, but it doesn't have anything. Anyways, I mean, you can get a lot of detail over here. So a list of the known partition types. So if I press L, it will show me the partition type. So Linux recognizes all these file systems, all these partitions it can recognize. So Linux is the one where Linux is actually installed. This is a Linux partition, so it recognizes NTFS as well. It recognizes almost all of the major ones, and there is FAT12 over here and so on. It recognizes almost all of the major ones. Then what I can do is I can see the partition table by doing P also. So I can type P over here to see the partition table. It will show me the partition table, which currently is for my SDA2, and SDA2 is where my Linux, this Ubuntu, is installed, and it shows that the file system is Linux because Linux is normally installed on Linux type of partition. This is what it's showing us. And you can do some other stuff also. For example, you wanted to create a new partition, so you can do that. I just wanted to make sure that I'm in the right partition. So SDA2 is the one I am in, and SDA5 is the one with that. Okay, so yeah, so this is what I have, and For example, I wanted to add a new partition. This is what you normally do if you have created a new hard drive, already formatted it. Next thing you want to do with it is to add a new partition to it, right? So this is N, right? So you press N over here and it will take you to this this prompt. So it will ask you, what do you want to create? You want to create a primary partition, I want to create an extended partition, right? Remember we did this. So there are two types of partitions. So within extended partition, obviously you can create logical partition, and it's telling you that you already have one primary partition, you have space for 3 more primary partitions. So you can create 3 more primary partitions if you want. So for that you have to press P. So I'll press P over here, and then it will ask you what you want to call this primary partition. I'll put default. So you can press enter and it will call this. What do you want to start your first sector of your primary partition? I'll keep default just like this, and it will say that created a new partition 2 of type Linux and of size 512 bytes, right? So it has done that for us. So if I see the partition table now, you can see that previously I had only this, now I have SDA 2P2 as well, right? So we have created a new partition for us. Obviously, I mean, for me, I will not do everything, but when you are doing it, you will have a separate space, and then you play with this. I don't have a separate space, so I'm not going to play with this. But that's how you normally do it, and you just follow this wizards, follow these commands. It's going to ask you the space also, how much space. But for me, obviously, I don't have free space. That's why it has just created a very, very small 512 bytes of partition for me. But normally if you have a partition of maybe, for example, 1 GB that you have left for your work on if there is an assignment you want to work on, then you can do it, play with that. And once you are done with this, what you can do is, if I want to go to my menu, you have to use a W to save whatever you have done and then exit. If I press Q, the changes what I have done, made a partition, they will not be saved, right? So in my case, I'm going to press a Q, but in your case, you're going to press W, because obviously the partitions you have created, you want to keep them, but I don't want to keep them, so I'm going to exit. So I have exited my Fdisk, right? Now, once you are done with partitioning your hard drive, you will have a hard drive, another partition of hard drive, besides the one where your Linux is installed. You will have another space, right? And on that space, what you're going to do is you're going to install a file system. You're going to install a file system. Remember, if you can follow this. Once you are done with partitioning, the next thing you have to do is you have to create a file system, right? So in order to create a file system, there is already a utility, default utility available in Linux. And normally if you're working on any Linux distribution, as I said that Linux normally follows the ext2, ext3 or ext4 type of partitions, and this is a good idea to do that, because they are pretty fast, and they offer you a journaling system also. What is a journaling system? A journaling system is that it keeps track of your file system. If something goes wrong with your file system, you can always recover. So that's why journaling systems are pretty in these days, or at least Linux, that's why Linux is considered very stable, and that's why most of the servers in the world they are built on Linux, because it's pretty stable because of the way it is built. So ext3 and ext4, they are journaling systems. They allow you to, if something goes wrong, you can always roll back to the previous one. So that's why you can do that. So in order to create a file system, there is a utility which is, I think, if I'm not wrong, it's Mkfs. So for creating a directory, you normally use mkdir, right, for directory. For creating a file system, you do Mkfs, make file system, Mkfs, right? And if you do a full stop, and if you double tap on it, it will show you all the utilities. So in order to create ext2 file system, you use mkfs.ext2 utility. For 3 you do this, for 4 you do this, and so on, right? So for example, if I wanted to do ext3, I'll do this, and then I will provide the path of my partition, the one I just created. For example, if my path was SDA, I don't know, to, I don't know, B, something like this, then I will provide that. And what this will do is it will create a file system for me. It will create a file system for me, which will be read by the operating system. Because if you create a partition, and you have not created a file system, operating system will not be able to read it, right? Operating system won't know that there is some more space that can be used to place some files, right? So if your file systems are not among the list of this, this is just a very short list, I guess, if I'm not wrong. There is a lot more that you can do. ext3 and ext4 might not be here because they are default ones which Linux can use, but definitely you can use ext3 and ext4. I mean, and they are highly recommended, so you can use that. So if the file system is from any of them, Linux can read it. Linux as an operating system can read that, right? So you have to create a file system using maybe this command. So for example, if I ask you an assignment, do mkfs.txt, if I ask you to create a file system of the extension 3 or 4, you use a utility like this. So once your file system is ready, so what you have done is you have partitioned your hard drive, then after that you are ready to or maybe you have already created a file system on that. So operating system now knows, okay, there is a space on the hard drive that I can read or write onto, right? But you have just made it ready, you have not told operating system that there is some more space, right? So in order to do that, you use a special command which is called mount. Mount means you mount your system, mount your partition, or you mount your partition that has a file system on the operating system, so that operating system knows that, okay, there is a partition available that has a file system where I can read and write. Right now, after this command, you have prepared everything for the operating system, but you have not told operating system anything that there is another place for it to read and write, right? In order for operating system to know that, you use mount, right? And mount is basically where is a command, and I would not tell you about this right now because I want you guys to go online and have a look at it. It's a very simple command. So you have to use a mount, and then where you place that, I mean, what do you want to mount and where do you want to mount, right? Only 2 parameters it takes, and these are just paths. So you just mount that, and once you have mounted that, it will start appearing in your file system over here. So for example, if I see now, I mean, in my case, I have, this is my original this is my original Linux where my Linux is installed, and this is the new partition, for example, I have created. This is SDB1, which I have just created, not just created, this is what I created before. So this is a partition where I can place my stuff. So your partition, if you have created a partition, then you have created a file system on it, and then you have mounted, then your stuff will appear over here as well, right? And obviously your networks will appear over here. So my MacBook is appearing in networks, and this is SF VM underscore share. You might have already know this, that this is for sharing between your hard drive and your between your guest operating system and your host operating system. So you can mount it. After mounting, as I just showed you, it will appear for you on your system as well, and you can play with this just like a regular hard drive, right? And you can write on a file on it, create directories on it, copy paste some files to and from it. So and that's how you mount. This is how you create your hard drive, partitions on your hard drive. This is how you build your file system on it, and then you can mount. And obviously, in order to unmount it, for example, you want to just get rid of this, you can use umount, which is unmount, and you can use this, right? So, and obviously, if you want to get some more information on this, you can use umount from here as well. So that's how you do it. And some of you might have already done this, or might have done something similar of partitioning your hard drive or so on, maybe at work, maybe you as a hobbyist. If you've not done this, I'll give you a chance through an assignment. So, and as you have seen that there are only 3-4 steps that you have to go through, and it's not going to be a very difficult assignment if you have just gone through what I told you. There are just few commands here and there, and just go through the wizard, and that's pretty much it. So that's why I don't want to make assignment number 3 very complicated for you, because we are not left with too much time as well. And I want you guys to feel a little bit comfortable going into the final exam, that you have scored a lot of marks, and then you can go to final exam and give your best to get more marks over there, right? And since it's going to be the end of the semester, I don't want to leave you guys with something. I don't want to give you a hard time over here. And why there is no need, right? The best part is that you are learning something new. The best part is you know how to implement it. You can at least go into the market and implement what you have learned. At least maybe you can build on top of what you have learned now. This is the whole aim. This is the whole aim of this course, and this is the whole aim of my teaching style. I mean, this is how it should be. So I think that's pretty much it. I don't want to stretch it more. What I'm gonna do is maybe in next lecture I will give you the assignment at the end of next lecture as well. I don't want to burden you now, but do expect that there is one more assignment coming up, and do expect that it's not going to be very difficult. I don't believe that even the previous two assignments were very difficult, right? I don't think so. Maybe one reason is you guys have understood the concept very well, and the other reason is maybe they were not difficult at all, right? So anyways, you guys have done brilliant job up till now. Keep doing that, and hope you guys understand whatever I'm telling you over here. You learn from here, and as always I keep on saying, if you don't learn, if you don't understand anything, if you think you have missed something, you cannot get your head around something, just meet me in my virtual office hours. I can see some students appearing, not a lot of them, but at least some students are appearing here and there in my virtual office hours for asking questions. That frequency of students increases when there is an assignment, which is absolutely fine, and you're most welcome to come and meet me over there. I mean, I'm free. I mean, you can ask other students as well who had a talk with me, that we discuss about other things as well, which are not maybe related to this course. So if you want to seek my advice on something, and you think I can advise you on something besides this course, you are free to join me and we can have a talk. And that's pretty much it. Just take care of yourself. We have some increasing cases of COVID-19 again, so keep yourself safe, guys. It's very important. Your health is very important. It's important you take care of your family as well. So I'll leave you on this note, and that's pretty much it for this week. Thank you very much. I'll see you in the next lecture. Bye bye.